from Idaho, I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy. Good morning from Idaho. We've got a beautiful spring day, end of March. No wind. About 55 degrees now, supposed to get up to 70. It's a great time to be outside. Okay, we're back on the Jeep again. We got a lot of projects for the Jeep this spring and summer. We're going to do full suspension, wheels and tires, lockers. But right now we're working on electronics. And this is a video as part of a sequence of videos about doing a onboard welder. An onboard welder is basically a welder that you carry around with you all the time. It's just built into the vehicle. And in this case, and in most cases, it is powered by the vehicle's alternator. So the next step for this project are, I want to move the alternator up to this position here, get it out of the mud, keep it alive longer, and then I will move the air compressor for the air conditioning down to that location, which may be a little bit harder because I've got to make my own brackets. No one's ever done this before, so we'll see how that goes. At any rate, once I get the alternator up here, then I'll upgrade it to a 160 amp alternator. Right now I've got a perfectly good 90 amp alternator. But if you run these things in much slop, mud, water, snow, whatever, the alternator doesn't live very long. So I'm going to move it up, and then once I move it up, I'll put a much better alternator on it. Anyway, with a 160 amp alternator, I'll be able to weld on the trail, in the parking lot, wherever you can take a Jeep. And so that moving it and putting on all new big cables, because I'm going to be generating a lot more power, and installing a control panel and a solenoid to switch back between charging and welding, and an external regulator is all part of this onboard welder. Well, none of that does me much good if I can't control the RPM precisely with some sort of a cable or mechanism or something that will allow me to open the throttle precisely and set the right voltage. So I'll be able to set the voltage to, somewhere in the range 18 to 24, which is typical welding voltages. That'll be DC. And then I'll also, by opening the throttle even more, be able to get it up to 125 volts DC, which will be enough voltage to run power tools. And most any power tool that has brushes in it, hand drills, angle grinders, whatever, will run from a DC source. It doesn't, the alternating current doesn't really help it. And so I'll be able to not only weld, but I'll be able to run a cutoff wheel, a grinder, whatever I need on the trail that's with the corded power tools. Or you could take along, battery powered tools as well. But at any rate, the project today is to put a manual throttle on the Jeep so that I'll be able to turn a knob and look at the voltmeter on my welding control box and set the voltage to, let's say in this case 21 volts, plug in my welding leads, go off and weld. And so I'm going to make a manual throttle out of some brass pieces just to keep it from corroding. And most of these are done with a big long cable, that costs $50 and whatnot. I can make this with a few pieces of brass and a 1/2-inch bolt, and move on, and then continue on my way. So let's get you in a little closer. Okay, I'm back. Okay, let's talk a little bit about how the Jeep throttle works. So this cable here goes underneath the dash and hooks to the foot throttle, and so when you push on the foot throttle, it pulls on that cable and rotates the diaphragm. This cable over here is for the automatic transmission kickdown. So when the foot throttle pulls this, we also pull this one. And so when it gets pulled out far enough and the RPM is correct and a bunch of other factors, it will kick down and shift. Well, notice there's this third hole. That's for cruise control. And so I went to the wrecking yard and bought a small piece of the cruise control, which includes the little end that snaps onto the throttle. So that'll snap on right here. In normal operation, it goes through here. This plastic piece snaps into that square hole, and then a vacuum solenoid pulls the cable in and out for cruise control. Well, I'm going to use the cable, but I'm going to replace the rest of it with something I'm going to make. So the first piece is a bolt that goes through this hole, and I've got a jam nut, and I'll clamp it on here like this. And I already recorded this yesterday, but it was too windy for you to hear anything, so I went ahead and made this part. Normally I wouldn't make any parts before I record the introduction, but anyway, I drilled a hole all the way through it and deburred the ends and cut it to length. And so we're at 2 5/16, and that'll clamp on there. Then I'm going to take this piece of brass and put 1/2-inch threads on the inside, so I will be able to turn it and it'll scoot in or out based on that bolt. And then on the center of it, down the center of it, will be my cable, and the cable will hook to this end. And so whenever I need more throttle to weld with, I'll just crank it out a little bit, and then I will lock it in that position, and the engine will maintain that same RPM long enough to weld or to grind or do whatever. And the third piece is I'm going to use a little sliver of this, about 3/8 of an inch, to make a lock nut, so that when I'm welding I just adjust the throttle on with that long brass, and then a little sliver of this will lock it. And just as important, when I'm not using the welder, which is 99% of the time, the cable will be slack here so that it has no effect on the throttle, and then I will lock the lock nut so that it doesn't interfere with normal driving. And that's basically all that it turns out to be, is just a little bit of lathe work, a little bit of harvesting parts from the wrecking yard, and a little bit of CAD drawing. That's where we're at right now. Okay, we're in the shop. Here's what we're going to make. Over here is the pin on the throttle lever and a cable. The clear piece here is the existing cable bracket. The green piece is the 1/2-inch bolt with a 1/4-inch hole down through the middle. And then the light blue pieces are the throttle adjustment knob and the lock. So we're going to start by making this the 1/2-inch bolt, putting the hole down through the middle and cutting it to length. You could just chuck this up in here and grip on the threads. That's a little crude, because you may get by with it, but it is not very good for the brass. And so what I like to do is take a piece of fence wire and wrap it around the bolt in the threads. And the wire will position itself in the thread, but it'll stick up a little bit higher than the thread and give the chuck jaws something to grip to without damaging the brass. I do this for metal bolts as well, steel and aluminum. And the only real constraint is that the wire needs to be thin enough that it doesn't touch when the threads are laid down next to each other. Okay, then you cut your wire to length, and this black mark here is the length I need to cut it to, which is 2 5/8. So we'll make that about a 1/2 inch from the wire. So I want 2 5/8. Just like that. And then I just align the cutter with the end. There's our hole all the way through the middle. Here's my little jam nut. Starts on there just fine. It looks like we're ready to move on to the next part. Okay, the next part is this. This is what I call the throttle handle. It's basically this 1-inch brass. There's a 2 1/8 inch threaded hole on one end and a 1/2 inch hole on the other. The 118 degree drill point is being used in both of those, and then it's a knurled finish with a chamfer. We're going to drill 2 1/8 inches and tap for 12/13, which is what our bolt is. Okay, let's see how we did. Okay. Looks like that's going to be outstanding. And so my jam nut will go up against this, like this. Yeah, one problem. I thought this was 1.5 inch brass. It's 1 1/4. Okay, we're gonna have to figure out something because I want my jam nut to stick up a little bit higher than that. Maybe what I ought to do is to make a plunge cut and go in and go in and go in and go in until I get down to 3/4, and then I'll have enough space to feel the ears on the jam nut. I think that's the solution. Okay, my compound's already set for 45, so that's good. We'll just go in 1 1/4. That'll still leave me 1 1/4 of knurl, which is plenty. Yeah, I think this is a good idea. Okay, I forgot to start filming when I started machining, but anyway, I'm cutting this recess. It's 3/8 of an inch down to the point of the drill bit, and it's 1/2 inches in diameter, and there's a 1/4 inch through hole. I've already done the 1/4 inch through hole, and I've already drilled this to depth, but let's take the bit out and inspect. Okay, we got a nice clean hole, nice smooth bottom. That's important because there's another piece that runs on the bottom. The through hole looks good. It looks like we're done with this piece. This thing needs a through hole that is 0.94. So we'll do that, and then we'll cut this taper on it, and then we can cut it off and put this cross hole in it for set screw. Okay, we've got our compound set to 28 degrees, ready to cut our taper. Okay, we got our taper. No way to know how well it fits, but anyway, we are good to go there. Now we can carve it off and then cross drill it. Yeah, it's hot. Not that hot. Anyway, this is supposed to go in there. And it's just below the surface, so we don't get hung up on it. I still have to clean off that little bit of parting swarf there. But the next trick is to cross drill it for 832 and tap it. And here is my cable. It goes in there like so. And then we'll cross drill it and put a set screw in there, and we'll be able to clamp the cable to the appropriate length. Okay, I got my stock in the milling machine. We're going to make the jam nut now. It's got some little features in it that require a milling machine. So let's see if the program will run. So that ought to be a pretty good knob to get a hold of to set the lock nut. Next steps happen in the lathe. Okay, we're back. All the machining is done. I got my little cable. I got my little lock here. So let's take it all apart and install it. Okay, you remember the basis for this was this big long brass bolt with a hole in the middle. And it goes through this bracket that the other cables go through. Give me a couple of 3/4 inch end wrenches. Should be able to tighten this up. Okay, that's good and tight. Next, we put on the jam nut. Okay. And then the throttle knob itself. Okay. Then here's our scrounged cable, which goes on this little pin here, which I've cleaned and lubricated already, and it just snaps on. Okay, which goes down through the center. And then we have our little ferrule that goes on. And we are going to want a little loop here of space so that there's no chance that this will ever come on when we're driving. That would be bad. So we'll just set our set screw. Got 2 set screws to set. Get them nice and tight. I'll put a drop of wicking Loctite on there. And then we cut off the excess. All right. I don't know where that went. I'll have to dig it out. And now we have our throttle cable. So let's show it working. Okay, this is our typical about 800 RPM. Yeah, it's about 900 RPM idle. But let's say we want to winch somebody out of a ditch and we want more electricity available to us to the winch. We just keep turning the throttle knob. This pulls on that cable. Then we can get locked. Any RPM we want. So for winching or welding, we'll be able to set the RPM at whatever is needed. And then we back it off, make sure we have plenty of slack, and lock it so that now this can't interfere with the throttle, which is this one right here. So with that, this part of the onboard welder is done. So goodbye from Idaho. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.